Alright, so let's go over Math 5's quiz number 14. Chapter 5.1 to 5.4. This was taken on March 6, 2018 before your spring break. Make sure to show all your work and box your answers. Next quiz, you're going to have this little section right here, and you will lose points for actually being messy and not boxing your answers. So I'm telling you, I'm warning you. I warned you for 14 quizzes. Now you will show. Question number 1. Determine the number of zeros possible for p of x. So this function, p of x, is a polynomial. Polynomial just means that you have an exponent with a number and there's multiple numbers. And you want to know, make sure that it's written in descending order. Descending order is when the numbers go down from the exponents. And when the numbers go down, I'm looking for the highest number. So for example, I don't have anything to the fourth power, which is totally fine. So 5, 3, 2, and then this is actually has a 0, x to the 0 power there. So I'm looking for the highest number, that's 5. Well, the highest degree tells me, so we can write this, highest degree, actually tells me the number of possible zeros. Which means the answer is C. And the reason why the answer is C is because, remember, it doesn't necessarily have to go through the x-axis. You can have a bounce above that, and that's your imaginary, right? So there you have 2, 4, and then there's your fifth one. Question number 2. Use the polynomial f of x equals negative 2x cubed plus 4x minus 8 and explain how the degree and leading coefficient will affect the end behavior. So the word degree is referring to the exponent. And the leading coefficient is talking about that negative, if there's a negative sign in front. And the word end behavior is just talking about those arrows. Remember, go back to the easiest odd degree you know. The easiest one is x to the first. What does x to the first look like? It starts down, ends up. The negative leading coefficient changes these points. So now the graph's going to look like this. Starts up, ends down. It's an odd degree, so you're going to have these arrows are in opposite directions. Evens will be in the same direction, like a quadratic. So the answer is B. The degree is odd, so we know all of these have odd, which is a good, that's why you couldn't eliminate it. Then the endpoints will be in opposite directions. Opposite directions. Let's see if they understood it. The ends opposite. Opposite directions. Okay, this one has same. So this contradicts the word, because this should be the word even. Again, same. So that's a contradiction, right? Same would have to be even, and this is not an even. It's an odd because of the 3. And because the leading coefficient is negative, the graph will decrease. So the word decrease, you're reading graphs from left to right. So here my graph, my hill, my roller coaster is going down from right to left. Okay, so that's the key word, decreasing. Question number 3. Determine algebraically whether the function is even, odd, or neither. This is not talking about not an even, odd, or neither degree. So remember, we kind of focused on that before. If I use the word degree, like up here, I'm actually looking at the exponent. Because I don't have the word degree, there's no degree, we're not looking at the small numbers here. I'm not looking at the 4 and the 2. What they're talking about here, this problem is about symmetry. Symmetry. So symmetry refers to which axis it's being symmetrical around. What do I have to do that algebraically? Sub every x with negative x. You guys remember that? So if I put in negative x here for every x value, negative x to the fourth power, remember that just means negative x times negative x times negative x times negative x. And that just gives me x to the fourth. So I have negative 3x to the fourth. Nothing's changed there. Over here I have negative x squared. Negative x times negative x is a positive x squared. And then you still have that subtraction sign. So you still have negative 3x minus x squared. Well, recognize that that's just the original problem. Remember, if it's the original problem, you have an even. I'm going to guess that the graph looks something like this. And you realize, remember, it's folded. My secret word is the word evenly. It's symmetrical about the y-axis. It would be odd if it's basically the same answer, but you can factor out a -1. And it would be a neither if it wasn't exactly the same or the opposite. If you recognize, that was actually a repeat question from a previous quiz. Question number 4. If you use y equals x to the third, this is what x to the third looks like. This is the parent function as a reference graph. Describe how you would graph y equals parentheses x plus 3 cubed minus 4. So some things you should have recognized. You can change that plus sign if you want. That helps. Y equals x minus negative 3 cubed minus 4. And you can also write the letters above it. Y equals a times x minus c cubed plus d. And you'll recognize here that your d value is -4, which means going down because it's negative. And then here, remember that minus sign has to be there, so your c value is -3. If your c value is -3, that means you actually go left. It's going to be shifted left. So your graph might look something like this. Left 3, up 4. Now there's also that silly phrase I gave you guys. Add to x. Go where? And west is where? Left. This is your adding to x. So this is a trick. This gives a better explanation. Question number 5. Identify the end behavior of the polynomial function f of x equals x cubed minus 3x minus 2. Remember, all of chapter 5 is basically cubic to the third power or quartic to the fourth power. Now, here's a nice thing. I graphed it for you. I could have not given you the graph and still give you the same multiple choice, and you would have to sketch the graph. So the first thing I notice is that there's no a value, so it's a positive. This is an odd, so like all odds, it's going to start down and up. And we already have that. See that? That's what it means by end behavior. So if you're studying, you're making flashcards, whatever it is, you're teaching your teddy bear how to do quiz corrections. The great thing about using end behavior is you should have that sentence frame. As x approaches something, f of x or y approaches this. And then as x approaches something, y approaches this. Now the reason why I chose C is as x, so x is going left or right. As you're going, now this, they mixed it up here. This says as x approaches negative infinity. So if you want to mark your graph, you can. Mark your graph with that. It says as x approaches negative infinity on the x values. So they're saying going this direction, that's going left. As you go left, what's happening to the graph? Well, if you're on that roller coaster, you're eventually going to be going down. You'll be screaming. So that's negative infinity, down. As x approaches positive infinity, so you're going on the x value, so left or right. The last thing I'm touching in there is an arrow that's going up. So this is going to the right, and this is up, your answer is C. Someone shout out a letter, A, B, or D?
A.
Let me explain why A is wrong. As x approaches negative infinity, so that's going left, this statement is saying the y values is going up. So as I'm going this direction, do you see an arrow going up? No, it's going down. As x approaches positive infinity, so this is going towards the right, y is approaching infinity, so that means going up. So this whole statement's actually correct. The only thing that's wrong is this part right there. So you should have on this side 1 point for your name written nice and neatly. Circle the period, that's 2 points, and each multiple place, 2, 4, 6, 8, 10, 12, and that's the max score for that side. Alright, on the back side, question number 6. Analyze the graph below. Circle the function which could model the graph, and describe your reasoning to either eliminate or choose a function. It's around prom time, so I just want to use the prom as an example, okay? You know, maybe it's like a TV show. You're given 3 people who want to take you to prom. Circle them one you want to go with. Are you just going to close your eyes and be like, eeny, meeny, miny, mo? No, you're like, man, he or she's too short for me. Write that down. Ew, it's kind of weird. They dated my brother or sister. Right? And you might write that down, right? It's an explanation why you said no. And you're like, oh, that person, they're perfect. Right? Because all my friend says so. I don't know. Right? But you have an explanation. And the reason why I make fun of that is because a lot of you guys just circled an answer and you don't explain your reasoning to both eliminate too short, dated my brother or sister, or choose each function. They're perfect for me. Does that make sense? Let's go through these. Now, when I look at this graph, I notice a couple of things. I recognize they're both pointing up. That's an even function. What type of function, class? Even. It's even. When they're in the same direction, both pointing up or both pointing down, that's an even. Now, if it's both pointing up, is the A value positive or negative? The A value is positive. Another word for the A value is leading coefficient. Here is a common mistake. Many of you you're still making the same mistake. I wrote this question up here in green. What's a negative? Because a lot of you just say that word arbitrarily. It's negative. What are you saying? This graph has a bad attitude? It's negative in life? Has a negative outlook on life? No. The A value you're saying here is negative. The leading coefficient is negative. Don't say it's negative. It's too broad. It's not specific. What? There's a negative in the equation? Does that make sense? You need to be specific. So a lot of you are just writing the word negative. I think some of you have a negative attitude about math. See? But I'm very specific, right? I'm not just saying you have a negative attitude about school. You might have a negative attitude about math. So be specific. So this one I eliminated because the leading coefficient is negative. This graph is going to look something like this. Do you see that? They're both pointing down. Let me, f of x. Now, this would be crazy. Some of you did, which is okay and perfectly fine. You multiplied all of this out. And then you took your answer and subtracted by 3. Let me show you a shortcut. You just take the x, and any exponents, and you just multiply them. Count with me. Ready, set, go.
1, 2, 3, 4, 5.
This is x to the 5th. This is an odd. Eliminated because the degree is odd and the graph shows an even. So here's a big idea we've been learning for the past 3 weeks. You can either write this one in the green box or this one over here. Because this is a 5, this one has max 5 zeros, or minus 1 4 extremas. Count the zeros with me. Ready, set, go. Count.
1, 2, 3, 4.
Actually, there's a bounce too. Do you see that one? So it's actually 6 in that one. So this one has 6 zeros, but over here this one only has 5. Does that make sense? So I gave you 3 points if you circled the correct one and you had some correct explanations, maybe not all of it. Okay. I gave you 2 points if you it was correct but no explanation, or maybe you have something correct. Okay. Although this was a lot of work to think through, it was only worth 4 points. So don't hang your head over it if you got it wrong. Again, the big idea is the degree tells you how many max possible number of x-intercepts, and then the number of extrema is just one less than that number. Remember, the extrema is the maximums and the minimums. Question number 7, fill in the blanks of the squares in each row and each column contain the digits 1 to 4. Numbers and cages may repeat as long as they are in the same row or column. So if I'm doing this problem, let's just say you've never done this before and you're struggling, I'm going to look for the freebies. The freebies are the ones that have a number but no plus or minus. So there's my freebie, 2. Are there any other freebies? Yeah, down here, 3. And then sometimes you do have to guess, but look over here. 2 numbers that add to be 3. That's 2 and 1. Now, you can see that I did some erasing. So if you put a 1 and a 2 here, you might have to eventually just go back and change the order of those. Does that make sense? Here's a cage, 2 numbers that subtract to be 3. This does not mean negative 3. 2 numbers that add to be 3 and 2. You're going to have to figure out, is that 4 and 1 or 3 and 2? Remember, they cannot be any repeating numbers. If you're still struggling with that, watch my video or ask. Question number 8. Draw a polynomial function with the following characteristics. There are 4 characteristics. Here's the first one. When I see that sentence, this sentence frame, you should automatically think end behavior. What are you thinking, class?
End behavior.
Those are the key words. End behavior, you should be thinking of this. As x approaches positive infinity. So here's the x-axis. And when you're going in this direction, these are positive numbers. So we call that positive infinity. Therefore, on the x-axis, this direction would be called the what? Class? Negative. On the y values are negative, so this is called the negative infinity, and going up is the positive. The end behavior says as x approaches positive infinity. Which direction is that?
Right.
You're going right. F of x is the same thing as saying the y values. It also needs to go up. So as I'm going in this direction, I need up. So what I like to do is I just like to draw an arrow that's pointing up. As x approaches negative infinity, that's left. The f of x values must be negative. This means down. So as I'm going from right to left, the very end there, it should be a negative. That's the first characteristic. The second characteristic tells us that the y-intercept should be negative 2. It just means the graph has to go through negative 2. So what I like to do is I just draw a point like this. The third characteristic says 3 x-intercepts. Now here it doesn't tell us anything specific. It doesn't say multiplicity, right? All it says is, it doesn't say distinct. That's a better word you can use, distinct 3 x-intercepts. So you can put them anywhere you want. I put them here, 1, 2, and 3. And then lastly, it says 2 relative extremas. That means I need a max and a min. So there they are. So when you're drawing your graph, you should be going through the x-intercepts and try to go through the y-intercept. And those And those orange points, the extremas will come. You can just double check, like, all right, I have those, okay? If you made a mistake on one of these, I gave you 3 points. I gave you 2 points if you made 2 mistakes. And I probably put an X by the bullet point that you missed to show you what you did wrong. Remember, in your quiz corrections, if there's not enough space, you might want to do it on a separate piece of paper or definitely in different colors. Question number 9. For f of x equals x to the third plus 4, write a rule for each function. So I just took that from the warm-up we did before, the day before. It tells us, write a rule. So g of x equals f of x plus 3. So every time I see f of x, I can write x cubed plus 4. Here's f of x. I'm going to write x cubed plus 4. Notice how that plus 3 is on the outside of f of x. Since there's addition, I don't need the parentheses. You can just add the 4 and the 3. The answer is x cubed plus 7. If you left it just like this, without the second part, describe the transformation, then you got 3 points out of 4. The transformation is, notice how the adding of 3 is on the outside. If it's on the outside, that's essentially the d value. So that's telling you going up 3 units. If you did the substitution, but you cannot simplify, I only gave you 2 points. If you only did the substitution and you knew up 3, then I'll probably give you 3 points. Question 9b, same thing. Every time you see, this one's a little bit harder. Every time you see f of x, you're going to write x cubed plus 4. Now, here is f of x. Essentially what you're writing there is x cubed plus 4. But here, do you see how that x minus 5 is inside the parentheses? Do you see that? That means that every x value, you're going to, instead of writing x, you're going to write x minus 5. So every x value, you're going to be writing x minus 5. Now a lot of you guys left it like that. That means you didn't really simplify, so you can take x minus 5 and just multiply, right? X minus 5 times x minus 5. Your answer is x squared minus 10x plus 25. And you do it one more time, and then you get this as your answer. Now be careful at the very end. A lot of you guys missed this. There's that plus 4 there. So whatever you multiplied and got here, you still have to add 4. So negative 125 plus 4 gives me negative 121. Because the minus 5 is inside the parentheses, you're going right 5 units. Remember, it's add to x, go left. Well, it's not going, there's no plus, so it's the opposite, which is right. There is an extra can down here, just in case you made a mistake on the other one. Try again. And then the point values on this problem were 4, 4, 4, 4, 4. 4 times 5 is 20. So then 20 plus 12 gives you the 32. And I told the other class that next quiz, which is on what day? Monday, or any printed quiz I give you. Now if you're messy in your writing, or you don't box your answers, you will now lose a point on your quiz or test. So write neatly. Hope this was helpful.